GenAI and MLOps Part 19. This episode has 7 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain offline versus online features. Here's a strong way to approach it. Offline features are features stored and used mainly for model training and batch processing, while online features are low-latency features used during real-time inference in production. Offline features, stored in data lakes, warehouses, or batch storage systems used for model training, analytics, and historical processing, handle large volumes of historical data optimized for throughput rather than low latency. Example: historical customer transactions stored in BigQuery or S3 for training recommendation models. Online features, stored in low-latency databases or in-memory systems used during real-time predictions optimized for fast read access, continuously updated with live data. Example: current user session activity or recent clickstream data used during live recommendation inference. In production ML systems, both online and offline features should remain consistent to avoid training serving skew. Feature stores usually manage both. Offline store for training datasets, online store for real-time serving. This architecture helps maintain scalability, consistency, and reliable model performance in MLOps environments. Nice. Let's continue. Question 2. What is batch inference? Here's a strong way to approach it. Batch inference is the process of running machine learning predictions on a large set of data at scheduled intervals instead of generating predictions in real time. In batch inference, data is collected over a period of time and processed together as a batch using a trained model. It is commonly used when real-time predictions are not required. Large volumes of data need processing. Cost optimization is important. Predictions can be generated periodically. Examples: daily sales forecasting, monthly fraud analysis, customer churn prediction, recommendation generation. Overnight batch inference workflows are usually executed using scheduled pipelines: Apache Airflow, Spark Jobs, Kubernetes, cron jobs. Cloud batch processing services. Advantages: cost-effective, easier to scale for large datasets, simpler infrastructure compared to real-time serving. Limitation: predictions are not instant because processing happens periodically. In MLOps, batch inference pipelines are typically automated, monitored, and integrated with data processing and storage systems. Great. Moving on. Question 3. What is real-time inference? Here's a strong way to approach it. Real-time inference is the process of generating predictions instantly when new input data is received by a machine learning model. In this approach, the model serves predictions with very low latency, usually within milliseconds or seconds, through APIs or online serving systems. Real-time inference is commonly used in applications where immediate responses are required, such as fraud detection, recommendation systems, chatbots, autonomous systems, credit card transaction validation, personalized advertising. Example: when a user opens an e-commerce application, the recommendation model instantly predicts and shows personalized products based on current user activity. Real-time inference systems are typically built using REST or gRPC APIs, Kubernetes model serving platforms, low-latency databases, and caching systems. Common tools include TensorFlow serving, K-Serve, Selden Core, NVIDIA Triton Inference Server. In MLOps, real-time inference requires high availability, low latency, autoscaling, monitoring, and continuous performance tracking. Alright, next question. Question 4. Explain shadow deployment in ML. Here's a strong way to approach it. Real-time inference is the process of generating predictions instantly when new input data is received by a machine learning model. In this approach, the model serves predictions with very low latency, usually within milliseconds or seconds, through APIs or online serving systems. Real-time inference is commonly used in applications where immediate responses are required, such as fraud detection, recommendation systems, chatbots, autonomous systems, credit card transaction validation, personalized advertising. Example: when a user opens an e-commerce application, the recommendation model instantly predicts and shows personalized products based on current user activity. Real-time inference systems are typically built using REST or gRPC APIs, Kubernetes model serving platforms, low-latency databases, and caching systems. Common tools include TensorFlow serving, K-Serve, Selden Core, NVIDIA Triton Inference Server. In MLOps, real-time inference requires high availability, low latency, autoscaling, monitoring, and continuous performance tracking. Let's keep going. Question 5. What is A or B testing for ML models? Here's a strong way to approach it. A or B testing for ML models is a technique used to compare the performance of two different machine learning models in a real production environment by splitting user traffic between them. Typically, Model A is the existing or baseline model, Model B is the new or updated model. Both models receive a portion of live traffic, and their performance is measured using business and technical metrics such as prediction accuracy, click-through rate, conversion rate, latency, revenue impact, user engagement. The goal is to determine whether the new model performs better than the current production model before fully rolling it out. Example: in a recommendation system, 90% of users may continue using the existing model, while 10% are routed to the new model for testing. A or B testing is important in MLOps because offline model accuracy alone does not guarantee better real-world performance. In production environments, A or B testing is usually implemented using traffic splitting, Kubernetes ingress or service mesh, Canary deployments, feature flags, monitoring and analytics platforms. It helps reduce deployment risk and enables data-driven model release decisions. On to the next one. Question 6. What is Canary deployment? Here's a strong way to approach it. Canary deployment is a deployment strategy where a new version of an application or ML model is released gradually to a small percentage of users before rolling it out to all users. The goal is to reduce deployment risk by testing the new version in a real production environment with limited traffic. In this approach, most traffic continues going to the stable version. A small portion of traffic is routed to the new version. Performance, errors, latency, and business metrics are monitored closely. If the new version performs well, traffic is gradually increased. If issues are detected, the deployment can be rolled back quickly with minimal impact. In MLOps, Canary deployment is commonly used for testing new ML models safely, monitoring prediction quality, detecting drift or performance issues, validating infrastructure changes. Canary deployments are typically implemented using Kubernetes service mesh tools like IceGeo ingress controllers, load balancers, CI or CD pipelines. This strategy improves deployment reliability, reduces downtime risk, and enables safer production releases. Good. Here's another one. Question 7. What is model rollback? Here's a strong way to approach it. Model rollback is the process of reverting from a newly deployed machine learning model back to a previous stable version when issues are detected in production. Rollback is usually performed when the new model causes problems such as reduced prediction accuracy, increased latency, model drift, business metric degradation, system failures, or unexpected behavior. In MLOps, rollback is important for maintaining system reliability and minimizing production impact. Example: if a newly deployed fraud detection model starts generating a high number of false positives, traffic can immediately be switched back to the previous stable model version. Model rollback is typically enabled through model versioning, CI or CD pipelines, Canary or blue-green deployments, Kubernetes deployments, model registries. Tools like MLflow, Kubeflow, and cloud model registries help manage rollback workflows efficiently in production environments. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.